Hey guys, how you doing? Good. I came from Brazil, especially for this conference, and I want to talk to you about serverless with Java, and I'm very glad to be here today. Anyone here works with Java? Great, I'm not alone today. Um, so let's present myself. My name is Evandro. I'm a software engineer working at a company called Conta Azul, and it's a Brazilian fintech that provides solutions for small business entrepreneurs and accountants too. And I have 15 years of experience, and basically my whole career is working with Java. I started very early as a programmer when I was 12 years old with Clipper because my father is a programmer too. And I'm a father of two kids too, Teodoro and Olivia, maybe programmers in the future, I don't know. And to start my presentation, I want to talk to you about some Java facts. And the first one is the Java is the first programming language in the world. And over again, Java has been the first programming language in the world. And because of that, Java has the biggest community in the world too. There is a high demand of jobs for Java programmers. Java is also used by big companies around the world. And 10 of 10 serverless developers hate Java. I'm kidding, but I think it's a fact too. So knowing all those facts, why Java isn't used with serverless? That's a question I made for myself when I started to study about serverless a few years ago. And I think it's a question it's alive today. And to talk about the relation between Java and serverless, we need to understand some things. And the first one is the cold start. That's a serverless main concept, and it's important to know about it. And basically, the cold start is the startup time of your function. So the first time you invoke your function, the provider needs to warm up your function, and this time of warm up is called cold start. And I draw this to explain better how the cold start works. And basically here I have a timeline with the time 1, time 2, and the time 3. And in the time 1, we have 3 invocations, 2 for the function 1 and 1 for the function 2. And in the time 1, we have the cold start for these 3 invocations because I did invoke these functions before. And in the time 2, I have 2 invocations, 1 for the function 1 and 1 for the function 2. And here we don't have the cold start because I already invoked before in the time 1. And in the time 3, I have 3 invocations for the function 1 and only 1 instance of my function I have the cold start because 2 I already invoked before. So that's a simple explanation about cold start. And here we have the startup time of the traditional JVM. And the JDK 10 has a startup time of almost 1 second. And the JDK 8 have a startup time of 800 milliseconds. So it's a high cold start here if you use traditional JVM. And that's important because the serverless pricing is based on execution time and memory usage. So if my cold start is higher and my startup time is higher, I will pay more for that. But knowing all those facts and informations, I was curious about how other programming language works with serverless. And I choose a simple use case to develop with different programming languages the same function, and doing that I want to perform a benchmark between these programming languages to understand how those programming languages works with serverless. And the use case I choose was the number in words. So basically, I receive an integer number, and the answer is this integer number in words. And I use serverless framework and IBM Cloud functions. My first function I made with Python, and here is the first invocation. The first invocation with cold start run in 300 milliseconds, and the second invocation without cold start in 3 milliseconds. My second function I made with Node.js, and the first invocation with cold start run in 91 milliseconds, and the second invocation without cold start run in 2 milliseconds. And with Java, my first invocation with cold start run in 200 milliseconds, and here we can see the efforts of the providers to use optimized JVMs for that purpose, because if we use a traditional JVM for serverless, the cold start will be higher. And here we can see the whole execution time was in 200 milliseconds. So it's good for Java. When I started to study about serverless, my first function run in 1 second with cold start. So that's a great thing to Java today. And the second invocation without cold start in 2 milliseconds. So Java was worse, not too worse, but was worse than Node.js, for example. So why use? I think the first thing you need to concern is about the know-how of your team, the time to market. Sometimes the time to market is more important for the company instead of paying a little bit more for that. So if you have a Java team, maybe it's a good idea to develop your function with Java. You have also the biggest community to help you solve your problems. And if you develop an asynchronous request, event-driven or triggered event, because for synchronous requests like a REST endpoint, maybe it's not a good idea because the cold start in 200 milliseconds, the user experience will be not too good. And I choose some best practices for serverless too, to develop with native Java. And the first one is develop your function stateless. That's something you need to do for any programming language, but it's always good to remember. And it's good to have a few or no one class path scanner or use of reflection, because these two things will increase your cold start, your startup time. So that's a good thing to avoid. You have to concern about use a low allocated memory for the JVM, because the serverless pricing is based on execution time and memory usage. So Java is known to use largest amount of memory, so we need to care about that. And use of lightweight libraries for basically that avoid all those things I said before. Okay. But we have a new hope for Java, and this hope is called Quarkus.io. Anyone knows about Quarkus.io? Okay. So Quarkus.io is self-described as a supersonic subatomic Java. It uses GraalVM to perform a ahead of time compilation. It means this framework will try to solve all those things in the compilation time instead of the startup time, like Spring Boot, for example. So it means the compilation time will be higher and the startup time will be very quick. And thank you, Red Hat and its developer, because Quarkus is a project from Red Hat, because here we can see some important data. In a REST application, in a traditional cloud native stack, we need to allocate 140 megabytes of memory. And in application with Quarkus and GraalVM, we need only 13 megabytes of memory. In a REST NJPA application, in a traditional cloud native stack, we need to allocate 200 megabytes of memory, and with Quarkus and GraalVM, we need only 35 megabytes. And talk about initialization time. In a traditional cloud native stack, in a REST application, we have a startup time of 4 seconds, and with Quarkus and GraalVM, it's 14 milliseconds. And in a REST NJPA application, in a traditional stack, we have almost 10 seconds of startup time, and with Quarkus and GraalVM, it's only 55 milliseconds. And it's easy to develop your functions with not only functions, but your application with Quarkus, because Quarkus is based on Java EE. So you have all those famous frameworks to develop your application, like REST-Easy, Hibernate, and Eclipse Microprofile, Kafka. So you have all those frameworks to develop your functions. So it's easy because you have a great community about those things. And now the time for the truth, because I developed the same function I made before with native Java. I made with Quarkus IO, and here the first invocation executed in 52 milliseconds with cold start. And here we can see the startup time of the Quarkus in 12 milliseconds. And the second invocation was in 2 milliseconds. So it's time to show the code. You can find all those code of Python, Node.js, Quarkus, and Java in my GitHub, but I will show you here my code for Quarkus. So basically, we have here a simple Quarkus application, and I create here a resource called the run. That's a pattern used in the IBM Cloud functions when we are using a Docker function. So I create that, and basically we need to create a Docker image exposing the port 88, and we need to have this endpoint called run. And here we can call my function and solve the number in word use case. And all the other things you need to run the Quarkus you can find in the Quarkus documentation. Is pretty easy to build. And here's some conclusions about what I talk about. The first one is choose a better programming language to solve your problem. So it's always good to remember, because not because Java is good now or any other thing. I think you need to concern about that. Not about technically things, but also what will be better for your company. I don't recommend using native Java for REST endpoints, because I said before, because of the cold start in 200 milliseconds, if you use that in a front end, for example, the user experience will not be too good. If possible, use Quarkus for your Java function. We saw that is very quick than native Java. If it's impossible, use the best practices I said before to build good Java function. And please don't hate Java programmers, because we also love serverless too. And I think it is. Conta Azul, we are hiring, so if you want to know more about that, just talk with me later. And I think it is. Thank you. I have a bonus here because I'm a nerd, and I did a serverless with Clipper. I was thinking my first day in programming, so I create, sorry, I'm a nerd, and remember my starting days as a programmer and a proof of concept. Even legacy language can be used with serverless. And I did a simple hello world with Clipper. It ran in 200 milliseconds, not too bad. So thank you very much.